Pluto is not frozen solid. It never has been. And 6 days ago we found out that it still isn't. A paper published on the 31st of July reported the first evidence of liquid flowing on Pluto's surface. Liquid nitrogen, rising through cracks in a glacier and wetting the ice from below, on a world whose midday temperature is minus 229 degrees Celsius. And that is not even the strangest part. The largest plain on Pluto is bigger than Texas and Oklahoma combined, and there is not one impact crater anywhere on it, which means that surface is being erased and rebuilt roughly every 500,000 years. Parts of that ground are younger than our species. Mountains of water ice float on a sea of frozen nitrogen. Red snow falls out of a blue sky. By the end of tonight you will know exactly what makes Pluto more disturbing than we thought, and it is none of the things I have just listed. Get comfortable. If you are the kind of person who enjoys finding out that something you were taught was settled was never actually measured, a quick like and subscribe helps this channel reach more curious minds like you. Because by the end of this, the word dead is not something you will apply to a world without checking first. Now, let's slowly settle in. On the 24th of August 2006, in a conference hall in Prague, 424 people raised their hands and a world stopped being a planet. That is the whole event. There was no observation involved. No new telescope had been pointed at Pluto that week. No probe had returned data. No measurement had been taken that changed a single physical property of the object itself. Pluto weighed exactly what it weighed the day before. It orbited on exactly the path it had always orbited. It was, in every way that a world can be described, entirely unchanged. What changed was a sentence in a document, adopted at the end of a long meeting, by the fraction of the attendees who had not yet gone home. There were roughly 9,000 members of the International Astronomical Union at the time. 424 of them voted. That is less than 5% of the world's professional astronomers, and the vote came on the final afternoon of a 10-day General Assembly, when much of the assembly had already left for the airport. Within days, more than 300 planetary scientists had signed a petition, rejecting the definition outright. Some of them had spent their entire careers studying the object that had just been reclassified out from under them. The definition itself has 3 parts, and it is worth knowing them, because the third one is where everything happens. To be a planet under the 2006 resolution, a body must orbit the Sun. Pluto does that. It must have enough mass that its own gravity has pulled it into a round shape, rather than leaving it a lumpy fragment. Pluto does that too. It is comfortably round, and it has been round for 4.5 billion years, and it must have cleared the neighbourhood around its orbit. Pluto does not do that. Pluto shares its region of space with an enormous population of icy bodies, and it does not gravitationally dominate them the way Earth dominates the asteroids that cross our path. By the numbers, Pluto misses that third criterion not by a little, but by roughly 4 orders of magnitude. It is not a close call, so the vote was defensible. That is not really the interesting part. The interesting part is what the vote did to how the rest of us looked at the object afterwards. Because a thing that has been officially demoted stops being interesting. It becomes a footnote, a piece of trivia, an answer to a pub quiz question about how many planets there are. For most people who were alive in 2006, Pluto simply moved from one mental category, real place, 9th planet, the far edge of the diagram on the classroom wall, into another one, which was debris, leftover, a cold lump on the outskirts, something that had been mistakenly promoted 76 years earlier and had now been quietly corrected. 76 years. That is how long it had been on the list, and it got there because of an error. Percival Lowell, a wealthy Bostonian who had built himself an observatory in Flagstaff, Arizona, spent the last decade of his life hunting for what he called Planet X. His reasoning was that the orbits of Uranus and Neptune showed small deviations from where Newtonian mechanics said they should be, and that those deviations could be explained by the gravitational pull of a large undiscovered world further out. He computed where it should be. He searched. He did not find it, and he died in 1916, and the search stopped for more than a decade. In 1929, the observatory hired a 22-year-old from a Kansas farm named Clyde Tombaugh. Tombaugh had no university degree. What he had was a set of telescopes he had built himself, grinding the mirrors by hand, using parts from a cream separator and pieces salvaged from a 1910 Buick. He had sent his drawings of Jupiter and Mars to Lowell Observatory hoping for an opinion, and instead they offered him a job operating the new photographic telescope. The job was this: photograph the same patch of sky twice, several nights apart. Then load both plates into a machine called a blink comparator, which flips your view rapidly back and forth between the two images. Everything that is a star will sit perfectly still. Anything that has moved between the two exposures will appear to jump. Each pair of plates carried tens of thousands, sometimes hundreds of thousands, of star images. Tombaugh did this, by eye, for months. On the 18th of February 1930, comparing plates taken on the 23rd and the 29th of January, he found a point of light that jumped. The announcement went out on the 13th of March, a date chosen because it was both Percival Lowell's birthday and the anniversary of the discovery of Uranus. Here is the error. Lowell's Planet X did not exist. The orbital deviations that had motivated the entire search were not caused by an undiscovered world at all. They were caused by using a slightly wrong value for the mass of Neptune. When Voyager 2 flew past Neptune in 1989 and measured its mass properly, the deviations vanished completely. There was nothing left to explain, and Pluto, as it turns out, is about 1/200th of the mass Lowell's calculation required. It could not possibly have produced the effect he was looking for. Pluto was found in almost exactly the predicted place, for entirely the wrong reason, by a young man with no formal training who was willing to look at several 100,000 points of light one pair at a time. It is one of the luckiest discoveries in the history of the field, and it was made by someone who had earned it through sheer patience. The name came from an 11-year-old girl. Venetia Burney was at breakfast in Oxford, England, in March of 1930, when her grandfather read out the newspaper story about the new world at the outer edge of the solar system. She suggested Pluto, for the Roman god of the underworld, on the grounds that a world that far out in the dark ought to be named for the ruler of the dark. Her grandfather passed the suggestion to a friend at the Bodleian Library, who cabled it to Flagstaff. The observatory staff voted on the shortlist, and Pluto won unanimously. It did not hurt that the first two letters were also Percival Lowell's initials, and then, across the following decades, Pluto shrank. In 1930 it was assumed to be roughly the size of Earth, because that was what the Planet X calculation demanded. By the 1940s, better observations had brought it down to something like the mass of Mars. By the 1960s it was smaller still. Each new measurement made it less impressive, and there was no way to pin it down properly, because Pluto was too small and too far away to show a resolvable disk in any telescope on Earth. The answer arrived on the 22nd of June, 1978. James Christie, working at the United States Naval Observatory Station in Flagstaff, was examining photographic plates of Pluto and noticed that the image had a persistent bump on one side. The bump moved around Pluto over a period of days. It was a moon, and it was enormous relative to its host, and its orbital period gave the total mass of the system directly and immediately. The result was brutal. Pluto has a mass of about 0.00218 Earths, roughly 1/459th of our planet. It is smaller than our own moon. It is smaller than 7 other moons in the solar system. The 9th planet turned out to be a body you could fit inside the continental United States, with room to spare on both coasts. By the time the 2006 vote came around, the case had been building for 30 years, and the discovery of Eris in 2005, a body in the same distant region, more massive than Pluto, made the situation untenable. Either Eris was the 10th planet or Pluto was not the 9th. So the hands went up, and Pluto came off the list, and the diagram on the classroom wall lost its outermost dot. And here is the sentence that this entire video exists to take apart. We called it dead because we never watched it long enough to see it move. Everything we believed about Pluto in 2006 was inherited rather than measured. Nobody had photographed its surface. Nobody had measured its diameter to better than about 40 kilometers. Nobody had seen a single feature on it. The picture in every textbook was an artist's impression of a grey, cratered ball, and that impression was not based on evidence. It was based on an assumption so old and so comfortable that nobody thought to label it as an assumption at all. 7 months before that vote in Prague, a spacecraft the size of a grand piano had already left Earth faster than anything humans have launched before or since, and it was heading directly for the object we were about to write off. New Horizons left Cape Canaveral on the 19th of January 2006, on top of an Atlas V with 5 solid rocket boosters and a third stage that had no other purpose than to throw this one small object away from the sun as hard as physics allows. It worked. The spacecraft left Earth at 16.26 kilometers per second, about 58,500 kilometers an hour, or 36,000 miles an hour. That is the fastest departure speed any human-built object has ever achieved from this planet, and 2 decades later it still is. It crossed the orbit of the Moon in 9 hours. Apollo 11, carrying people, took 3 days to cover the same distance. The spacecraft itself is not large. It weighed 478 kilograms at launch and is roughly the shape and size of a grand piano, with a 2-meter dish antenna bolted to the top of it. There are no solar panels anywhere on it, because at Pluto's distance sunlight is about 1 part in 1600 of what falls on Earth, and solar power at that intensity is not power, it is a rounding error. Instead, it carries a radioisotope thermoelectric generator holding 10.9 kilograms of plutonium-238, which converts the heat of radioactive decay directly into electricity. At Pluto, it was producing about 200 watts. That is less than 3 household light bulbs, and it had to run the computers, the heaters, the radio, and all 7 scientific instruments, which together draw about 28 watts. On the 28th of February, 2007, 13 months after launch, New Horizons flew past Jupiter and stole some of its orbital momentum. The maneuver added roughly 4 kilometers per second to its speed and cut 3 years off the journey. That is the entire reason the flyby happened in 2015 rather than 2018, and it is the reason the mission's principal investigator has said more than once that the launch window was not negotiable. Then came the waiting, 9.5 years of it. For most of that time, the spacecraft was asleep. New Horizons spent about 1,873 days, very close to 2/3 of the entire cruise, in electronic hibernation, split across 18 separate periods. Most systems were powered down. A single onboard timer ran, and once a week the spacecraft transmitted a simple beacon tone, a signal with almost no information in it beyond a color code that meant either everything is fine or please wake me up and look at this. Then it went back to sleep. The point was partly to preserve the electronics, and partly to reduce the cost of continuous tracking on the deep space network, which is a scarce and expensive resource that dozens of missions are competing for at any moment. There is something almost unbearable about the arithmetic of this. The people who built this spacecraft, who designed its instruments and wrote its command sequences, spent 9.5 years doing something else while it coasted. Careers advanced, children were born and started school. The mission's own target was reclassified out of the category it had launched toward, and the object at the end of the flight remained, in every image humanity possessed, a smear of a few pixels across. Then, 10 days out, it nearly ended. On the 4th of July, 2015, the main computer was doing 2 demanding things at once. It was compressing 63 encounter command sequences and writing them to flash memory, and it simply ran out of capacity. The system did exactly what it was designed to do in that situation, which is give up safely. It went into safe mode, handed control to the backup computer, and stopped what it was doing, which meant it stopped talking. The signal was gone for 81 minutes. Understand the position this put people in. Pluto was 4 hours and 25 minutes away at the speed of light. Every command sent to the spacecraft took 4 hours and 25 minutes to arrive, and any acknowledgement took another 4 hours and 25 minutes to come back. A single question and answer cost nearly 9 hours. The team had 3 days to diagnose the fault, reload the encounter sequence, and get the spacecraft back on schedule, using a communications link with a 9-hour round trip, for an event that could not be postponed by even a second, because the geometry of the solar system does not negotiate. They did it. They lost about 30 scientific observations out of a plan that had been rehearsed for 9 years, and they got everything else back. Closest approach came at 11 hours, 49 minutes and 57 seconds. Universal time on the 14th of July 2015. New Horizons passed 12,472 kilometers above Pluto's surface, a distance smaller than the width of Earth, moving at 13.78 kilometers per second, about 31,000 miles an hour. There was no orbit. There was no slowing down. Stopping at Pluto would have required carrying an amount of fuel that no rocket built by anyone could have lifted. So the mission was always going to be a single pass, at full speed, with one chance. and for the whole of the encounter, the spacecraft was not pointed at Earth. It could not observe and transmit at the same time, so it turned its instruments toward Pluto and turned its antenna away and went silent for 22 hours. There was one further thing nobody could rule out until 3 weeks before arrival, which was whether Pluto had a ring, or a debris field, or a population of small unseen fragments orbiting somewhere along the flight path. At 13.78 kilometers per second, a particle the size of a grain of rice carries the kinetic energy of a hand grenade, and the spacecraft has no shielding worth the name. The team had prepared an alternative trajectory, informally the bailout, which would have flown a safer, more distant path with substantially reduced science return. They spent the approach searching for anything orbiting Pluto that had not been seen before. They found nothing, and they held the original course, and the decision was made by people who understood exactly what they were risking. It is the evening of the 14th of July, 2015, at the Johns Hopkins Applied Physics Laboratory in Maryland, and a room full of people are waiting for a machine to tell them whether it is still alive. Some of them have been working on this since the 1980s, when it was a proposal that kept getting cancelled. Some of them joined out of graduate school and are now in their 40s. Nobody in the room can do anything. The spacecraft has been out of contact since the previous evening. It has already flown past Pluto. That happened before lunch, 4.5 light hours away, and whatever it did, it has already finished doing. The outcome is fixed. It is simply that the news has not arrived yet. At 52 minutes and 37 seconds past 8 in the evening Eastern Time, a signal reaches the Deep Space Network antenna and is relayed to the room. It is not a picture. There are no pictures for hours yet. It is 15 minutes of engineering telemetry, solid-state recorder status, power levels, attitude data, error counts, and it says that the spacecraft executed its sequence, that its memory is full, and that nothing went wrong. The room comes apart. People are shouting at a scrolling column of numbers, and the thing they are cheering has been true for 4.5 hours already, out at the edge of the sunlight, where nobody was watching. There is one more passenger to account for. Clyde Tombaugh spent the rest of his life defending Pluto's status as a planet. He taught astronomy in New Mexico, discovered 14 asteroids and a comet, and estimated that over his career he had examined something like 90 million star images by eye. He died on the 17th of January 1997, 9 years before New Horizons launched. About 30 grams of his ashes are bolted to the inside of the spacecraft's upper deck, in a small aluminium container inscribed by the mission's principal investigator. On the 14th of July 2015, those ashes passed 12,000 kilometers above the surface of the world he had found by blinking 2 photographic plates back and forth in 1930 at 31,000 miles an hour and did not stop. They are still going. They are at this moment further from the sun than any human remains have ever been, and there is no mechanism by which that will ever cease to be true. He is the only person in history to reach his own discovery, and he did it 18 years after his death, at a speed that made stopping impossible. The pictures started arriving the next morning, and what came down the link was not the world anybody had prepared for. The picture that arrived on the 15th of July 2015 was the last full-disk image taken before closest approach, and the first one in which Pluto was a place rather than a smudge. Across the middle of it, tilted slightly, sat a bright shape roughly the size of a continent, with 2 lobes at the top and a point at the bottom. It was, unmistakably and ridiculously, a heart. The internet did what the internet does. Within a day the image was everywhere, and the framing was universally affectionate. The little world that got demoted has a heart. The outcast is sending us a love letter, and so on. It was charming. It was also, in almost every respect that matters, backwards. Because the thing that the shape actually indicated, to anyone who understood what they were looking at, was not sentiment. It was a problem. Start with what everybody expected instead. Pluto is small. Its diameter is 2,376.6 kilometers, which is about 18.5% of Earth's, and roughly 2/3 the width of our own moon. It sits between about 30 and 49 times as far from the sun as we do. It receives on average about 1/1600th of the sunlight Earth receives. Its surface temperature is around 44 Kelvin, minus 229 degrees Celsius, minus 380 degrees Fahrenheit, cold enough that nitrogen, the gas that makes up most of the air you're breathing right now, lies on the ground as snow. Small bodies lose their internal heat quickly, because heat escapes through a surface and is stored in a volume, and as an object gets smaller, its surface area shrinks more slowly than its volume does. That is why the Moon is geologically dead and Earth is not. Pluto is smaller than the Moon. It should have finished cooling billions of years ago, and with nothing left to resurface it, its face should be a record, a complete, undisturbed archive of every impact it has taken since the solar system settled down, which is to say a sphere so densely cratered that the craters overlap. That is what every artist's impression before 2015 showed. Go and look at the pre-encounter press material from the mission itself, and you will find grey, pitted, lifeless spheres. That was not laziness. It was the consensus expectation, and it was reasonable, and it was wrong. The bright heart-shaped region got the informal name Tombor Regio. Its western lobe, the larger, smoother, brighter half, is called Sputnik Planitia, and it is the single most important surface on the outer solar system. It measures roughly 1,000 kilometers by 800. To put that in terms, you can stand inside. It is larger than Texas and Oklahoma combined. It sits between 2.5 and 3.5 kilometers below the terrain around it, in what is almost certainly an ancient impact basin, gouged out by a body several hundred kilometers across at some point in the distant past. And it is flooded is the better word, with frozen nitrogen in a layer somewhere between 3 and 10 kilometers thick. There is enough nitrogen ice sitting in that one basin to be comparable to a serious fraction of all the nitrogen in Earth's entire atmosphere, piled in one place, frozen solid. The flyby also settled a question that had been open since 1930. Before the encounter, Pluto's radius was known to within roughly 40 kilometers, which sounds precise until you realize that the uncertainty in the radius propagates straight into the density, and the density is the only handle anyone has on what a world is made of. New Horizons closed that uncertainty to about half a kilometer. The resulting mean density is 1.854 grams per cubic centimeter, and that number carries a specific and rather unromantic meaning. Pluto is roughly 2/3 rock and 1/3 ice by mass. It is not a snowball. It is a rocky body wearing an ice coat, with a rocky core estimated at something like 1,700 kilometers across, wrapped in an ice shell on the order of 200 kilometers thick. A world made mostly of rock has something a world made mostly of ice does not, which is a reservoir of radioactive elements slowly decaying in its interior and releasing heat. Hold on to that. And the basin is not a sealed bathtub. Around the eastern rim of Sputnik Planitia, the images show valleys running down from the highlands into the plain, and in those valleys there are flow lines, long parallel streaks curving around obstacles, converging where two valleys meet, exactly the pattern of medial moraines on an alpine glacier photographed from an aircraft. These are nitrogen glaciers, flowing downhill into the basin, and they are visually indistinguishable from the water glaciers of Earth, apart from being made of the wrong substance. There is a full drainage network. Material comes off the uplands, works its way down the valleys, and pools in the low ground, which means the plain is not a static deposit. It is the bottom of a system. But none of that is the observation that mattered. The observation that mattered is a negative one, and it is the reason we are having this conversation at all. Across the whole of Sputnik Planitia, New Horizons found no impact craters. Not a small one, not a degraded one, not an ambiguous one that people argued about. 0 confirmed impact structures across an area larger than most countries on Earth. Now, that could mean one of two things, and only one of them survives contact with the rest of the data. It could mean nothing hits Pluto. That would be convenient, and it is completely false. The region of space Pluto occupies is populated by well over 100,000 objects larger than 100 kilometers across, and an enormous number of smaller ones, and they collide constantly. We can check this directly on Pluto itself. Along Pluto's equator runs a dark reddish band called Cthulhu Macula, roughly 3,000 kilometers long and 750 wide, and it is saturated with craters, layered, overlapping, ancient. Best estimates put that surface at around 4 billion years old. It has been sitting there taking hits since the solar system was young, and it has the scars to prove it. So the impacts happen. They happen on Pluto, they just do not stay on Sputnik Planitia. Which leaves the second explanation, and it is the one that reorganizes everything you thought you knew about small cold worlds. The surface of Sputnik Planitia is being destroyed and rebuilt faster than impacts can accumulate on it. This is worth stating carefully, because it is the load-bearing inference of the entire encounter. A surface with no craters is a clock. Craters are not decoration. They are a timer that runs at a roughly known rate everywhere in the solar system. If you find a surface with a certain crater density, you can read off its age. If you find a surface with no craters at all, you have not found an absence of information. You have found a surface younger than the interval it takes to accumulate the first one. For Sputnik Planitia, that upper limit is around 10 million years, and most of the people who work on this think the real number is far lower, plausibly 500,000 years, possibly less. Sit with that for a moment, because the comparison is not abstract. Our species has existed in something like its current form for roughly 300,000 years. If the lower estimates are right, then parts of the ground on Sputnik Planitia are younger than we are. There is terrain out there, 4.5 billion kilometers away, on a world that receives a 1600th of our sunlight, that came into existence after the first humans were already walking around on this one. And when New Horizons got close enough to resolve the plane properly, we could see the mechanism doing it. The images show that Sputnik Planitia is not a smooth sheet. It is divided into cells, irregular polygons, typically 10 to 40 kilometers across, packed together across the entire plane like the segments of a cracked eggshell, or the pattern that forms on the surface of drying mud, or the top of a very slow pan of soup. Each cell is separated from its neighbors by a shallow trough, and each cell is very slightly domed, with about 100 meters of relief between its center and its edge, high in the middle. We could see this at all because of a telescopic camera on the spacecraft called LORRI, which on the best covered parts of the encounter hemisphere reached about 80 meters per pixel. That is close enough to resolve a city block. Scattered across the cells are pits, sublimation pits, tens to hundreds of meters wide, formed where nitrogen has been quietly evaporating from the surface into the atmosphere. And those pits turn out to matter enormously because they are carried along by whatever the plane is doing. They are markers dropped onto a moving surface. That shape is a signature, and it is not ambiguous. High in the center, low at the margins, arranged in polygons. That is what convection looks like. Something is rising in the middle of each cell, spreading outward across the surface, cooling and sinking back down at the boundary. Something in that plane is turning over. There is a piece of fluid physics that makes this less surprising than it first sounds, and more surprising once you follow it through. Whether a layer of material convects or just sits there is governed by a single dimensionless number, the Rayleigh number, which weighs the buoyancy driving the motion against the viscosity and thermal diffusion resisting it. Above a critical value, convection is not merely possible, it is unavoidable, and nitrogen ice at 40 Kelvin is extraordinarily soft. Its viscosity is on the order of 1,000,000 times lower than water ice at the same temperature. Water ice at 40 Kelvin is essentially rock. Nitrogen ice at 40 Kelvin behaves like something you could push a spoon through if you were patient enough. Run the numbers for a layer several kilometers thick with even a trickle of heat coming up from below, and the Rayleigh number is not marginally above critical. It is orders of magnitude above it. Which raises the obvious question, and it is a question about heat. Convection requires a temperature difference. Something has to be warmer at the bottom than at the top, by enough to keep the material moving against its own internal friction, continuously, for long enough to erase every crater on a landscape the size of 2 American states. On a world that should have gone cold before the first cells appeared in Earth's oceans, something down there is still supplying heat, and the plane has been using it to eat its own history. There is a particular kind of motion that human beings are very badly equipped to notice, and Sputnik Planitia is made of it. We are good at detecting things that move at roughly the speed a predator moves, or the speed a thrown rock moves. Everything faster than that we see as a blur, and everything slower than that we see as stationary. The plane on Pluto moves at about 10 centimeters a year. If you stood on it for your entire life, you would not detect a single moment of motion. Nothing would ever appear to shift, and in 100,000 years the surface you were standing on would be gone. The number is not a guess. In 2016, 2 independent teams published convection models in Nature, one led by William McKinnon, one led by Alex Trowbridge, showing that the polygonal cells on the plane are the surface expression of solid-state convection in the nitrogen ice layer, and estimating how fast that convection turns over. Later work by Jamie Buehler and Andrew Ingersoll went a step further and measured the speed rather than modelling it, using those sublimation pits as tracers. If pits form at random across the surface, and the surface is moving, then the pits will be swept along, and their distribution across each cell will encode the flow. Their result was a surface velocity of around 10 centimeters per year. It is worth pausing on how clever that measurement is, because it is a beautiful piece of work done with no instrument at all beyond a camera and a great deal of thought. Nobody watched the plane move. Nobody could. New Horizons was there for a few hours, and the surface travels a fraction of a millimeter in that time. What Buhler and Ingersoll did instead was reason backwards from a distribution. Sublimation pits open up more or less at random across the plane, and once open, they grow. If the surface was stationary, pits of all ages would be scattered uniformly across each cell. If the surface is flowing outward from the center, then a pit that formed near the center has been traveling for a long time by the moment it reaches the margin, and so pits should get systematically larger and more numerous the further out you look. That gradient is measurable in the images. The steepness of the gradient gives you the speed. It is the same logic a hydrologist uses to work out how fast a river is running by looking at the sorting of the gravel on its bed. 10 centimeters a year is the rate a fingernail grows. It is the speed of a continent drifting. It is in fact right in the range of Earth's tectonic plates, which move between about 1 and 10 centimeters a year, meaning that the plane on Pluto is resurfacing itself at continental drift speed, on a body 1/459th the mass of Earth, with a heat flow around 3% of Earth per square meter. Put the cell geometry together with the velocity, and you get the important number. The cells are 10 to 40 kilometers across. Material rises at the center, travels outward at 10 centimeters a year, and descends at the margin. The full circuit, the time it takes for the entire visible surface of the plane to be dragged under and replaced by material from below, is about 500,000 years. That is the clock. That is why there are no craters. Every impact scar that has ever formed on Sputnik Planitia has been carried sideways to a cell boundary and pulled down into the ice, and the record of it has been destroyed, not buried, not eroded, consumed and recycled. Now hold that in your mind and consider what it looks like from the surface. You're standing at the center of one of these cells. The ground is nitrogen ice, hard as concrete at this temperature, faintly translucent, with a dusting of something reddish on it. You're on the high point. The cell is domed, and its center stands about 100 meters above its rim, which is a slope so gentle you would never perceive it as a slope. The nearest cell boundary is somewhere between 5 and 20 kilometers away, which on a body this small is somewhere near the horizon, because Pluto's horizon is close. The sky above you is black, not dark blue, not dusk, black at midday, with a sun in it that is a single brilliant point rather than a disk, casting shadows with edges as sharp as a knife. Nothing is happening. That is the first thing you would report. There is no wind because at 1 pascal of pressure there is essentially nothing to blow. There is no sound for the same reason. Nothing falls, nothing shifts, nothing creaks. The stillness is total and it is permanent, and you are moving. Beneath you, several kilometers down, nitrogen ice warmed by the last of a 4.5 billion-year-old fire is rising toward the surface, spreading out under your feet, carrying you outward. You're drifting toward the edge of the cell at 10 centimeters a year. In a human lifetime, you will travel about 8 meters. In 10,000 years, a kilometer. Over roughly 250,000 years, you will reach the trough at the cell margin. The ground beneath you will tilt down, and you will begin to descend, and the surface you spent 250,000 years crossing will fold under and be gone. Meanwhile, behind you, at the point where you started, fresh material has been rising the whole time and pushing outward in every direction. The plane has not changed shape. Every cell is doing this simultaneously, has been doing it for an unknown length of time, and will keep doing it until the heat runs out. It is the least dramatic process imaginable, and it has erased 4 billion years of impacts. This is the point where the word for what Pluto is doing has to change, because we have a word for a body that resurfaces itself continuously through convection driven by internal heat, and that word is not dead. It is not dormant. The technical term for a world that does this is active, and the only other bodies in the solar system that do anything comparable are Earth, Io, Enceladus, Europa, Titan, Triton, and a handful of maybes. Pluto's on that list. Pluto has been on that list since 2015, and most people who left school before then have never been told. And notice what every other name on that list has that Pluto does not. Io is squeezed by Jupiter and by its resonance with Europa and Ganymede, and the flexing generates enough heat to run 400 active volcanoes. Enceladus is squeezed by Saturn, which is why it sprays water into space from its south pole. Europa is squeezed by Jupiter. Triton is a captured object with an eccentric history and a great deal of tidal energy in its past. Earth is large enough to have retained its own accretion heat and rich enough in radioactive elements to keep topping it up. Every active world we know of has a visible, quantifiable energy supply, and in most cases that supply is a large neighbour pulling the body out of shape twice per orbit. Pluto has no such supply. Pluto and Charon are locked to one another in a perfectly circular, fully synchronized orbit. Each keeps the same face toward the other, permanently. There is no periodic flexing. There is no tidal heating worth calculating. The one mechanism that powers almost every other active world in the solar system is, in Pluto's case, switched off. There is a further consequence, and it is stranger than the resurfacing. The plane does not merely erase impacts, it erases everything. Anything deposited on Sputnik Planitia from outside, a fragment of a comet, a piece of debris knocked off Charon, a scattering of dust, a spacecraft, in principle a monument, is on a conveyor belt. It will be carried horizontally at 10 centimeters a year to the nearest cell boundary, and then dragged downward into a several kilometer thick layer of nitrogen ice, and it will not come back. Pluto's largest landform is a machine for removing evidence. It is worth being concrete about the scale of the reservoir doing this, because the numbers are not intuitive. The nitrogen layer is estimated at 3 to 10 kilometers thick, across a plane 1,000 kilometers by 800. Even at the low end, that is a volume of frozen nitrogen measured in millions of cubic kilometers. Roughly 78% of the air in your lungs right now is nitrogen, and the total mass of Earth's atmosphere is about 5 million billion tons, and a serious fraction of that quantity of nitrogen is lying in one basin on Pluto as a solid, several kilometers deep, slowly turning over. Earth keeps its nitrogen as a gas because Earth is warm. Pluto keeps its nitrogen as bedrock because Pluto is not. The difference between an atmosphere and a landscape on these two worlds is about 250 degrees. That has a real scientific cost, which is worth naming. On Earth, plate tectonics has destroyed most of our own planet's early record. The oldest surviving crust is around 4 billion years old, and the story of the first half-billion years is almost entirely gone. On the Moon, nothing has been destroyed, which is why we go there to read the history of the inner solar system. Sputnik Planitia is at the extreme end of that spectrum. It holds no history at all. It is a landscape with total amnesia, and whatever happened on it before about 500,000 years ago is not recoverable by any means we can imagine. But the same process that destroys the record proves the thing the record would have told us. You do not get convection without a heat source. You do not get 500,000 years of continuous overturn from a body that cooled off 4 billion years ago. Something under that plane is warm, in a relative sense, and it has stayed warm, and it is still feeding energy upward into a layer of nitrogen ice on a world that receives 1/1600th of Earth's sunlight and has no tidal heating whatsoever. Where is that heat coming from? The honest answer, for a decade after the flyby, was a shrug and a hypothesis. Radioactive decay in the rocky core, probably, which is real, but small. Pluto's total interior heat flow is estimated at around 3 milliwatts per square meter. Earth's is about 87. Pluto's running a continental-scale convection engine on roughly 3% of Earth's heat flux per unit area, and the models that make that work require the heat to be routed and concentrated in ways that were, frankly, tuned to fit the observation. And then, this month, someone went back to the 11-year-old images with a fresh set of eyes and found something on the northern edge of that plane that nobody had explained, and that changes the character of the problem completely. On the 31st of July, 2026, 6 days ago, as this is being recorded, a paper appeared in the Planetary Science Journal reporting the first evidence of recently flowing liquid on the surface of Pluto. NASA released the finding publicly on the 5th of August. Read that sentence again slowly because every word in it is doing work. Not liquid in the past, not liquid inferred from a chemical signature, not liquid deep underground. Liquid on the surface recently, on a world whose midday temperature is minus 229 degrees Celsius. The lead author is Alan Stern, the principal investigator of the New Horizons mission at the Southwest Research Institute in Boulder, Colorado. The author list is unusual in a way that turns out to be the whole point. Alongside the Pluto specialists, there are terrestrial glaciologists, people whose expertise is in the behavior of ice sheets on Earth, in Antarctica and Greenland. That combination is not decoration. It is the method. Here is what they found. Along the northern edge of Sputnik Planitia, there are dark features. Some of them are thin and linear, narrow dark lines. Others are broad and diffuse, smudges, patches, regions where the ice is simply less bright than the ice around it. They were visible in the 2015 imagery. They had been noticed. They had not been explained, and they had never been the headline, because in the initial flood of results from the flyby, there were 100 things competing for attention, and a few dark streaks on a glacier were not the most urgent of them. What the new paper did was compare those features systematically against a catalogue of terrestrial glacier surfaces, and the match it found is specific. The dark features on northern Sputnik Planitia look like glacier ice that has been wetted. On Earth, when liquid water falls onto a glacier as rain, or seeps up onto it from below, the surface darkens in a characteristic way. The liquid fills the microscopic air spaces in the near-surface ice. The ice stops scattering light so efficiently, and the wetted area photographs darker than the dry area beside it. The pattern of that darkening has a shape, and the shape on Pluto matches. So the immediate question is, wetted by what? Not by water. Water on Pluto is bedrock. At 40 Kelvin it has the mechanical properties of granite, and it will not melt for any reason available on that world. The candidate is nitrogen, because nitrogen is what the plane is made of. And that raises an immediate and apparently fatal objection, which the paper has to answer before it can say anything else. Nitrogen cannot be a liquid on Pluto's surface. This is not a matter of opinion. It is a matter of the phase diagram, which is one of the most reliably known things in physical chemistry. Nitrogen's triple point, the unique combination of temperature and pressure at which solid, liquid and gas can coexist, and below which the liquid phase simply does not exist at all, sits at 63.15 Kelvin and 12.52 kilopascals. Below that pressure, nitrogen has only two options. It can be a solid, or it can be a gas, and it goes directly between the two without ever passing through liquid. The same thing happens to carbon dioxide at Earth's surface pressure, which is why dry ice does not melt into a puddle, it sublimates straight into vapor. Pluto's surface pressure is about 1 Pascal. The triple point requires 12,520. Pluto's atmosphere is more than 10,000 times too thin for liquid nitrogen to exist on the ground for even an instant. And the paper agrees. It rules out rain explicitly. Liquid nitrogen falling from Pluto's sky is not merely unobserved, it is physically forbidden by the conditions of the atmosphere. Whatever wetted that ice did not come from above, which leaves exactly one direction, and it is the direction that makes this result significant. Pressure is not the same everywhere on a world. It rises as you go down, because everything above you is pressing on you. Under an ocean on Earth, the pressure at 4 kilometers depth is around 400 atmospheres. Under an ice sheet, the same principle applies with a different density, and Sputnik Planitia is not a thin frost. It is a layer of nitrogen ice somewhere between 3 and 10 kilometers thick. At the base of a nitrogen glacier that thick, the pressure from the overlying ice is not 1 Pascal. It is far past the triple point. Down there, in the dark, at the boundary between the bottom of the ice and whatever Pluto's crust is made of, the pressure condition for liquid nitrogen is satisfied. All that is required is heat, enough of a temperature gradient from the interior to push the base of the glacier above 63 Kelvin. And the process has a name. It is not a new idea invented for Pluto. It is borrowed, wholesale, from Antarctic glaciology, and it is called basal melting. On Earth, this is well documented and thoroughly studied. Beneath the Antarctic ice sheet, the combination of geothermal heat from the rock below and the insulating blanket of 3 or 4 kilometers of ice above means that in many places the base of the ice sheet is at its melting point. Water forms there. It pools. There are more than 600 known subglacial lakes under Antarctica, the largest being Lake Vostok, sealed beneath nearly 4 kilometers of ice and isolated for something on the order of 15 million years. This is not exotic physics. It is a standard, well-understood consequence of putting a thick enough insulator on top of a warm enough floor. The Pluto argument is the same equation with different constants. Substitute nitrogen ice for water ice. Substitute a triple point of 63 Kelvin for 273. Substitute a heat flow of 3 milliwatts per square meter for Earth's 87, and ask whether the base of the glacier crosses its melting curve. Under a thick enough section, with enough heat coming up beneath it, it does. Then the liquid has to get out. And here the mechanism is again borrowed from terrestrial glaciology. Liquid at the base of an ice sheet is under pressure. Ice sheets are not monolithic. They are riddled with fractures and weaknesses, particularly near their margins, and pressurized liquid finds those weaknesses and travels up them. On Earth, subglacial water surfaces at the edges of ice sheets constantly. On Pluto, when liquid nitrogen reaches the top of those cracks, it emerges into a near vacuum, wets the surrounding ice, and then rapidly boils away, but not before it has darkened the surface it touched. Which brings us to the detail that Stern singled out, and it is the one that I find hardest to stop thinking about. If this is what is happening, then those dark patches are not permanent. They come and go. They are a time-variable feature, which means that when New Horizons flew past in 2015, it did not photograph a landscape. It photographed a moment. Something was happening on Pluto that week. Not over geological time, that week. And we have exactly one photograph of it, taken by a machine that was leaving at 31,000 miles an hour and is never coming back, and there is no spacecraft in existence, and no funded mission on any agency's books that could go and check whether those patches are still there. Stern's own comment on the result was 4 words long. Pluto never stops surprising us. There is a geometric detail in the paper that quietly strengthens the whole case, and it is easy to miss. The dark features cut across the boundaries between convection cells. They overprint the polygonal pattern rather than being contained within it, which means they are younger than the convection pattern they lie on top of. And the convection pattern, as we established, has an outside age of a few 100,000 years, and is probably far younger than that. So the wetting is not an ancient event preserved in the ice. It is recent even by the standards of a surface that is already the youngest large landscape known outside Earth. And consider what this does to a very short list. The number of bodies in the solar system with confirmed liquid on their surfaces has, until now, been 2. Earth, obviously with its water, and Titan, Saturn's largest moon, where methane and ethane fill genuine lakes and seas, Ligeia Mare, Kraken Mare, mapped by radar from the Cassini orbiter, complete with shorelines, river deltas and evidence of rainfall. 2 worlds, that was the inventory. Everywhere else in the solar system, liquid at the surface is either impossible or has to be qualified into meaninglessness. Brief flows of briny water on Mars that may or may not be liquid, and that is the end of the list. If this result holds, the number is 3, and the third entry is the object we voted off the planet list because it was too small and too far out to matter. The last thing to sit with about this discovery is how it was made. Nobody went back. Nobody built a new instrument. There was no second flyby, no orbiter, no lander, no fresh data of any kind. Somebody took imagery that has been sitting in a public archive since 2016, imagery that any person listening to this could download tonight, put it next to photographs of wet glaciers in Antarctica, and noticed that they looked the same. The most significant finding about Pluto in 11 years came from looking harder at pictures we already had. There is one more thing to hold on to from this, and it is a matter of language rather than physics. Liquid nitrogen has a reputation on Earth as the coldest thing most people will ever encounter. The stuff that shatters a rose, that fogs off the lip of a dewar in a laboratory, that people are warned not to touch. Its triple point is 63 Kelvin. Pluto's surface averages around 44, so on Pluto liquid nitrogen is warm. It is roughly 20 degrees above ambient. It is, relative to its surroundings, a hot spring. Warm is a relative word. Remember that because it comes back at the end of this, and when it does it will not be about nitrogen. Everything so far has been about the plane, the flattest, smoothest, most featureless surface on the world. But Sputnik Planitia has edges, and at the edges the physics of what is solid and what is liquid stops being merely unfamiliar and starts being genuinely inverted. Every intuition you have about what is hard and what is soft, what is ground and what is weather, what floats and what sinks, was calibrated at around 300 Kelvin. Pluto operates at 40, and at 40 Kelvin the entire hierarchy inverts. Start with water. On Earth, water is the archetypal soft, mobile, forgiving substance. It flows, it wets, it freezes into something brittle enough to break under a boot. Ice on Earth is temporary. It melts in your hand, it retreats in summer, it is the least permanent landscape feature we have. At 40 Kelvin, water ice is not any of those things. Its molecular structure locks up completely. It does not creep, it does not flow, it does not deform under load on any timescale that matters. Its mechanical strength approaches that of rock, and in some measures exceeds it. Water ice at Pluto's surface temperature has been compared to granite, and the comparison is not a flourish. It is the closest available analogy. So on Pluto, water ice is the bedrock. It is the geology. It is the continental crust, the mountain-building material, the hard floor that everything else sits on. It has been there since the world formed, and it will still be there when the sun has finished dying. And the things that behave like geology on Pluto, that flow, that erode, that fill basins, that carve valleys, that glaciate, that pile into drifts, are nitrogen, methane, and carbon monoxide. The gases, the substances that on Earth are air and exhaust, and the contents of a fire extinguisher are on Pluto the rivers and the glaciers and the snow. Once you accept that inversion, the landscape starts to make a terrible kind of sense. Along the southwestern shore of Sputnik Planitia stands a range called Norgay Montes, named for Tenzing Norgay, one of the two men who first stood on the summit of Everest. Its peaks rise 2 to 3 kilometers above the plain, the highest of them at something around 11,000 feet, which puts them in the same class as the Alps. They are jagged, they are angular, they cast long, hard-edged shadows in the New Horizons images, which is how their heights were measured in the first place. They are made entirely of water ice, not ice-covered rock, not rock with ice on top, blocks of frozen water, kilometers tall, standing as durable structural massifs, because at that temperature that is what frozen water does. A little further along the shore is a smaller range called Hillary Montes, for Edmund Hillary, which is exactly the sort of thing that happens when you let planetary scientists name mountains. Now go round to the northwest shore, to a region called Al Idrisi Montes, and the situation becomes genuinely strange. Here the water ice blocks are not standing in an orderly range, they are jumbled. Blocks 10 to 40 kilometers across sit at odd angles, tilted, rotated, jammed against one another, piled up along the boundary between the highlands and the plain in a chaotic mass that looks, and there is no better word, like a traffic accident. The explanation involves two numbers. Solid nitrogen has a density of about 1.03 grams per cubic centimeter. Water ice at these temperatures has a density of about 0.92 to 0.94. Water ice is less dense than nitrogen ice, which means that on Pluto, water floats on nitrogen. Not metaphorically, those mountains are floating. Blocks of water ice bedrock have carved off the highlands at the edge of the basin, drifted out onto the nitrogen glacier, and are being carried by it, slowly, at the pace the plane moves, until they ground against each other or against the shore and pile up. They are icebergs. They are icebergs made of water, in a sea made of nitrogen, and each individual iceberg is the size of a mountain range. Let me put you on that shore for a moment, because the arithmetic does not convey it. You are standing on the northwestern edge of Sputnik Planitia at local noon. The ground under your boots is water ice with the hardness of granite, dusted with something reddish that has settled out of the sky. The sun is up. It is not a disk. At this distance it is a point of light, brilliant, sharp, casting shadows with edges like cut paper. It is roughly 1,000th of the brightness you're used to, which sounds like darkness, and is not. It is around 300 times brighter than a full moon on Earth. It is bright enough to read a book by, and the sky behind it is black. Not dusk, not dark blue, black with stars in it at midday. There is no wind. At 1 Pascal there is nothing to push. There is no sound of any kind. Not the absence of noise you get in a quiet room, but the total absence of a medium that could carry noise at all. Nothing moves. You weigh about 6 kilograms. Gravity here is 0.62 meters per second squared, about 1/16th of Earth's, and a casual step would carry you several meters. Ahead of you, the plane runs out to a horizon that is much too close, because Pluto is small, and the curve falls away fast. And sitting out on that plane, tilted at angles that no landscape on Earth would permit, are mountains, not distant peaks on the far side. Mountains adrift, 10 to 40 kilometers across, leaning, some of them jammed together at their bases, arranged like blocks of pack ice photographed from the deck of a ship in the Arctic, except that each block is the size of a small country, and each one is made of frozen water resting on frozen air. None of it is moving. All of it is moving. You would need to stand there for 1,000 years to see the difference. Go east, past the heart, and the ground changes again. A region called Tartarus Dorsa is covered in ridges, parallel blades of nearly pure methane ice, running north to south, up to 500 meters tall, spaced 3 to 5 kilometers apart, marching across hundreds of kilometers of terrain in ranks. The terrestrial analogue is a formation called a penitente. In the high, dry Andes, at altitude, where the air is thin and the sunlight is fierce and it never rains, snow does not melt evenly. It sublimates, and tiny irregularities focus the sunlight, and the hollows deepen faster than the ridges, and eventually the snowfield turns into a forest of thin vertical spires that lean toward the sun. Mountaineers have been walking through them for 2 centuries, and they gave them the name because they look like a procession of hooded monks. Terrestrial penitents are, at their most impressive, a few meters tall. Pluto's are 500. They are the same process, run for millions of years, on a world where nothing ever disturbs them, no rain, no wind, no seasons in the terrestrial sense, no weather to knock them down. Outside Earth, this is the only place in the solar system where the formation has been identified. And then there are the 2 structures that nobody has fully explained. Right Mons is about 150 kilometers across and 4 to 5 kilometers high, with a substantial depression in the middle of it. Picard Mons is bigger, around 225 kilometers across and about 7 kilometers high. Both are irregular, lumpy, hummocky, and both have that central pit. In March of 2022, Kelsey Singer and colleagues published an analysis in Nature Communications of a region roughly 600 by 300 kilometers around these features, and their conclusion was that these are not 2 volcanoes. They are composite structures, many separate domes built by many separate vents, merged together over time into a single mass. What erupted from them was not molten rock, but a slurry of water ice, thick and viscous, mixed with something that kept it mobile. The terrain is essentially crater-free. The upper age limit the authors could put on it is 1 to 2 billion years, and they are explicit that the real age could be very much lower. Right Mons alone has a volume comparable to Mauna Loa, which is the largest volcano on Earth by that measure, a structure so heavy it has visibly bent the floor of the Pacific Ocean beneath it. Pluto built one of those, out of ice, in the dark, with almost no energy. There is a chemistry problem embedded in this that is worth stating, because it constrains what actually came out of those vents. Liquid water erupted onto Pluto's surface at 1 Pascal would not flow anywhere. It would flash to vapor almost instantly, the way water boils in a vacuum chamber at room temperature. For a cryovolcano to build a mountain, the erupted material has to be thick, a slurry, a paste, something closer to wet cement than to lava, and it has to stay coherent long enough to pile up rather than dissipate. The leading candidate for what makes that possible is ammonia. Even a few % of ammonia mixed into water dramatically lowers the freezing point and changes the viscosity of the mixture, and ammonia has in fact been detected spectroscopically on Charon and, closer to home, in a region of Pluto called Virgil Fossé. That detection carries a bonus implication that borders on the unreasonable. Ammonia exposed at a surface is broken down by radiation on a timescale of roughly 1 billion years. If we can still see it, it has not been there 1 billion years. Something put it there more recently than that. And Virgil Fossé is part of a larger pattern. Radiating outward from Sputnik Planitia is a system of long, straight troughs, Inanna Fossa, Virgil Fossé and others, that are extensional features. They are cracks. They are the marks left by a crust that has been pulled apart rather than squeezed together. Pluto's surface shows essentially no compressional tectonics anywhere. It shows a world that has been getting bigger. Nothing gets bigger by cooling. Rock contracts as it cools, so does almost everything. There is one common substance in the solar system that expands when it freezes, by about 9%, and you have watched it crack a bottle in a freezer. Hold that thought as well. So, cryovolcanoes. Ice volcanoes, possibly recent, on a world with no tidal heating, 3 milliwatts per square metre of internal heat, and a mass of 1/459th of Earth's. Every feature in this part points the same direction, down, into the interior, toward a heat source nobody has satisfactorily identified. But there is another half of Pluto that has to be accounted for before that argument can be closed, and it is the half that is not solid at all. It is above your head, it is bleeding into space, and it is currently painting the whole world red. The most beautiful image New Horizons ever took was taken while it was leaving. About 15 minutes after closest approach, the spacecraft turned and looked back, with Pluto now between it and the Sun. What it saw was a black disk, the unlit night side, surrounded by a ring of light, and the ring was blue. Pluto has a blue sky. That is not a poetic way of describing something else. It is a straightforward optical fact, and the physics that produces it is a close cousin of the physics that makes Earth's sky blue, which is that small particles scatter short wavelengths of light more efficiently than long ones. On Earth, the scattering particles are the nitrogen and oxygen molecules themselves. On Pluto, they are something considerably less pleasant. Pluto's atmosphere is about 99% nitrogen, with roughly 0.5% methane, about 0.05% carbon monoxide, and traces of heavier things: acetylene, ethylene, ethane, hydrogen cyanide. The surface pressure is about 1 pascal, which is roughly 100,000th of the pressure at sea level on Earth. It is, by any ordinary standard, a vacuum. A human standing on Pluto without a suit would be about 6,000 times below the pressure at which body fluids begin to boil at body temperature. And yet the atmosphere is enormous. It extends 1,600 kilometers above the surface and possibly more, which is to say, further out from Pluto than Pluto itself is wide. It is a thin, cold, distended envelope wrapped around a small world, and it is doing several things nobody predicted. The first surprise was structure. The backlit departure images resolved the haze into layers, at least 20 distinct strata, stacked one above the other, spaced roughly 10 kilometers apart, reaching up to about 200 kilometers altitude. Nobody predicted 20 layers. Nobody has fully explained them yet either. The leading candidate is gravity waves, oscillations propagating upward from the surface topography and organizing the haze into sheets, but the argument is not closed. The second surprise, and the one that runs through the rest of this story, is what the haze is made of and where it comes from. The process starts at the top. Ultraviolet light from the sun, feeble at this distance but perfectly capable of breaking chemical bonds, strikes methane molecules in the upper atmosphere and tears them apart. The fragments are reactive, and they do what reactive carbon fragments do. They combine into heavier molecules: acetylene, ethylene, ethane. Then heavier again, incorporating nitrogen, producing nitriles like hydrogen cyanide. Then heavier still, polymerizing into large, complex, irregular organic macromolecules with no single formula. These molecules condense into aerosol particles. The particles collide and stick, growing into fractal aggregates, loose, fluffy, chain-like structures with an enormous amount of surface area for very little mass. And then, being heavier than the gas around them, they fall. The general term for this class of material is tholin, from a Greek word meaning muddy. Tholins are found across the outer solar system, on Titan, on Triton, on comet nuclei, on the surfaces of Kuiper belt objects, and they are reddish-brown. On the way down through Pluto's atmosphere, they are further processed by ultraviolet light and by charged particles, which darkens them further. So the sky is blue because the particles in it are small enough to scatter blue light, and the particles are made of a material that is, in bulk, the colour of rust, and they rain. Continuously, everywhere, for 4.5 billion years. That is what stains Pluto. The dark reddish band running along its equator, Cthulhu Macula, roughly 3,000 kilometers long and 750 wide, is fallout. It is the accumulated residue of organic soot precipitating out of the sky onto a surface that has not been resurfaced, layered and relayered until the ground is the colour of dried blood. And it is saturated with impact craters, which is how we know it has been sitting there for something like 4 billion years collecting the stuff. That is the contrast the flyby handed us in a single frame. On one side of the world, an ancient dark red cratered plain that has recorded everything. Right next to it, a bright white crater-free plain that has recorded nothing, because it eats its own surface every 500,000 years. Two landscapes on the same small world, differing in age by roughly the entire history of the solar system. There is a comparison worth drawing here, because it explains why we can see Pluto's surface at all. Titan runs the same chemistry: ultraviolet light, methane, nitrogen, tholins. And Titan's haze is so thick that for 3 decades after the Voyager flybys, nobody had any idea what the surface underneath it looked like. It took radar and infrared windows and a probe dropped through the clouds to find out. Pluto's haze is made of the same material by the same process, but there is so much less of it that the atmosphere is essentially transparent. We got a clear view of the ground on the first attempt through an atmosphere that is doing the same thing Titan's is doing, simply at 100,000th of the pressure, and Pluto's thin air does something Earth's does not, which is invert. Methane is a greenhouse gas here as it is everywhere, and in Pluto's atmosphere it absorbs enough sunlight to warm the layer a few kilometers up above the temperature of the ground beneath it. The air over Pluto is warmer than the surface it sits on. If you could hang a thermometer above the plane, it would read higher the further you raised it, at least for the first several kilometers. On Earth that arrangement happens occasionally, over cold ground on a still night, and it traps smog in valleys. On Pluto it is the standing condition. The seasons are stranger still, and they are driven less by distance than by tilt. Pluto's axis is inclined 119.6 degrees, which means it is not merely tipped over like Uranus, it is tipped past the horizontal so that it rotates backwards relative to its orbit. The consequence is that Pluto's polar regions do not have days and nights in any recognizable sense. They have decades of continuous darkness, followed by decades of continuous light, cycling across an orbit that takes 248 years to complete. Nitrogen sublimates off the illuminated hemisphere, and cold traps onto the dark one, and the whole atmosphere migrates from pole to pole across the course of a Plutonian year. What we call weather on Pluto is really the slow relocation of the entire atmosphere from one end of the world to the other. Now to the result that genuinely broke a model. Before the flyby, everyone expected Pluto's upper atmosphere to be warm, around 100 Kelvin, because that is what the physics of an absorbing methane-rich upper atmosphere predicts. New Horizons measured about 70. 30 Kelvin colder than theory allowed, which in an atmosphere this simple is not a discrepancy. It is a failure. The explanation came in 2017 in a paper in Nature by Shi Zhang, Daryl Strobel and Hiroshi Imanaka, and it inverts the usual relationship between haze and temperature. On Earth, and on most worlds we understand, gas molecules do the cooling. They absorb energy, they radiate it away in the infrared, and the efficiency of that process sets the temperature. Aerosols are usually a complication, not the main term. On Pluto the aerosols are the main term. Those fractal tholin aggregates have so much surface area relative to their mass that they radiate heat into space far more efficiently than any gas molecule in the atmosphere can. They absorb sunlight, they re-emit it in the infrared, and the net effect is that they refrigerate the upper atmosphere below what gas phase chemistry alone would permit. Pluto has the only known haze-cooled atmosphere in the solar system. In 2025, a spectroscopic study using the James Webb Space Telescope's mid-infrared instrument confirmed the mechanism by detecting that thermal emission directly, and characterized the grains as Titan-style tholins wrapped in thin films of hydrocarbon and nitrile ice. The prediction was tested and it held, and that cold upper atmosphere has a consequence which nobody saw coming and which matters enormously for the rest of Pluto's story. Before the encounter, the expectation was that Pluto would be bleeding. A body this small has a very shallow gravity well. Escape velocity from Pluto is about 1.2 kilometers per second, roughly a tenth of Earth's, and a warm upper atmosphere would be losing nitrogen to space rapidly, in a process called hydrodynamic escape, essentially blowing off the top of the atmosphere continuously. Some pre-flyby estimates had Pluto losing enough material to be visibly eroding. The measured escape rate came in roughly 2 orders of magnitude below prediction, 100 times slower. Because the upper atmosphere is 30 Kelvin colder than expected, the molecules up there are moving far too sluggishly to escape in bulk, and the loss is a slow trickle rather than a torrent, which produces a genuinely odd chain of causation. Ultraviolet light destroys Pluto's methane, which builds soot, which falls and stains the surface red, and the same soot on its way down keeps the atmosphere cold enough that Pluto gets to keep the atmosphere at all. The material that is ruining the view is also the reason there is anything left to see. Pluto is being held together by its own pollution, but the balance is not permanent, and it is not stable, and for the last few years we have been watching it start to fail, using a technique so minimal it barely qualifies as an instrument. There is exactly one way to measure Pluto's atmosphere from Earth, and it involves no spacecraft, no orbiter, and no instrument more exotic than a telescope pointed at a star at the right moment. Pluto, seen from here, is about 1/10 of an arcsecond across. That is a golf ball at 30 kilometers. No telescope on this planet and no telescope in orbit around this planet can resolve its disk into anything more than a smear. You cannot photograph its atmosphere. You cannot take its spectrum in any useful way. From Earth, Pluto is a point of light of the 15th magnitude, and that is all it will ever be. But every so often, Pluto passes directly in front of a background star, and when that happens, something happens to the starlight that carries the entire atmosphere in it. If Pluto had no atmosphere, the star would simply switch off. One frame it is there, the next frame it is gone, a hard edge as the solid limb of the world crosses in front of it. That is what happens with an airless body. Pluto's star does not switch off. It fades. The light dims gradually over a couple of seconds, because before the solid surface reaches the star, the atmosphere does, and the atmosphere refracts, bending the starlight away from you by an amount that depends on the density of the gas the light is passing through. The shape of the fade is a direct readout of density as a function of altitude, and from density and altitude you can extract pressure and temperature all the way down. The whole measurement lasts under 2 minutes, which is why the people who do this live a slightly ridiculous professional life. The shadow of Pluto's atmosphere sweeps across the surface of the Earth in a path a few thousand kilometers wide, moving at kilometers per second, and it lands where the geometry says it will land. Sometimes that is a mountaintop with a permanent observatory on it. More often it is a stretch of desert, an airstrip in a country nobody at the Institute has visited before, a patch of coastline, or the middle of an ocean, in which case you charter an aircraft and fly into the shadow. So a team packs portable telescopes into flight cases. They fly, they drive, they set up on some flat piece of ground with generators and laptops, in the dark, and they check the weather every hour with the specific dread of people whose entire year hinges on one patch of sky staying clear for 120 seconds. Then, at the predicted instant, a star that has been sitting steadily in the field begins to fade. It does not blink. It softens. It goes down like a dimmer being turned, and then Pluto's surface occults it entirely, and then a minute later it comes back the same way. Somebody in a camping chair in the middle of nowhere has just measured the atmospheric pressure of a world 4.5 billion kilometers away by watching a star get slightly less bright. Do that repeatedly, across years, and you get a record. And the record is where this gets uncomfortable. The first good occultation measurements were made in 1988. Between then and 2015, Pluto's atmospheric pressure roughly tripled. That is the opposite of what you would naively expect, because Pluto passed its closest point to the Sun in 1989 and has been moving away ever since. It should have been getting colder, and its atmosphere should have been thinning. Instead, it thickened for nearly 3 decades, while the sunlight it received was steadily declining. The explanation is thermal lag, and it comes back to that extreme axial tilt. Pluto's northern hemisphere has been coming into sunlight over this period after decades in darkness, and the nitrogen frost deposited there over the long polar night has been sublimating faster than the increasing distance from the Sun can suppress it. The seasonal cycle and the orbital cycle are out of phase, and for a while the seasonal cycle won. It is worth appreciating that the entire existence of Pluto's atmosphere was discovered this way. Before 1988, nobody knew whether Pluto had any air at all. There were arguments both ways. Then an occultation was observed, partly from an aircraft, the Kuiper Airborne Observatory, flying above the weather with a telescope pointed out of a hole in its side, and the star did not snap off. It faded. That gradual fade was the discovery. An atmosphere was announced on the strength of the shape of a curve, and everything we have talked about since, the haze, the tholins, the blue sky, the seasonal migration, descends from that one observation. New Horizons did a version of the same experiment on its way out, using radio rather than starlight. As the spacecraft passed behind Pluto as seen from Earth, the giant dishes of the Deep Space Network transmitted a signal to it, and the instrument called RX measured how that signal was bent and delayed as it grazed the atmosphere on the way in and out. It gave a pressure and temperature profile right down to the surface, which anchored all the ground-based occultation work that has followed. Then, around 2021, the pressure plateaued, and then it began to fall. A study published this year in the Planetary Science Journal analysed 10 stellar occultations recorded between 2017 and 2023 and found a clear deflation beginning around 2022, a drop in atmospheric pressure of as much as 16%. Another occultation on the 1st of June 2026 continues the monitoring. 16% of a world's atmosphere gone in about 2 years. This had been predicted for decades. As Pluto continues outward toward its most distant point, which it will not reach until the year 2237, the nitrogen currently in the atmosphere is expected to condense back onto the surface, and the atmosphere is expected to substantially collapse. What the new work provides is the first observational confirmation that the collapse has started. The models are no longer forecasting, they are being verified. Whether it goes all the way is genuinely unsettled. The most current volatile transport models suggest a large decline, but not necessarily a total collapse, and the reason is a name you have already heard, Sputnik Planitia. That basin holds an enormous reservoir of nitrogen ice, and a large enough reservoir at a slightly warmer temperature can keep resupplying the atmosphere by sublimation even as the rest of the world freezes out. The plane may act as a buffer, a thermal flywheel that keeps a thin atmosphere going through the coldest part of the orbit. It is worth being clear about what a collapse would actually look like, because it is not violent. Nothing explodes, nothing blows away. The pressure simply falls year by year as more nitrogen freezes onto the ground than sublimates off it, until the number reaches a value indistinguishable from zero. The haze thins and then stops forming because there is no longer enough methane in the air to make it. The blue ring around the limb disappears, the temperature inversion goes, the migration of frost from pole to pole slows and then stops, and the surface, no longer being resupplied from the sky, stops changing in the way it currently does. Although what happens to the convection in Sputnik Planitia is a separate question, since that is driven from below and does not care what the sky is doing. And then, a century or so later, as Pluto swings back toward the Sun, all of it comes back. This has presumably happened hundreds of times. Every 248 years, Pluto exhales an atmosphere and then inhales it again, and we happen to have arrived with instruments during one exhale, near the end of it, in time to watch the beginning of the inhale, which is a good moment to stop and put the pieces together, because we are halfway through, and the picture has become more connected than it may have seemed. Everything we have looked at so far is one system. The nitrogen in Sputnik Planitia is not a separate thing from the nitrogen in the atmosphere. It is the same nitrogen, in a different phase, on a very slow circuit. Heat from the interior drives convection in the plane, which turns the surface over every 500,000 years, which keeps exposing fresh nitrogen ice. Sunlight sublimates that nitrogen into the atmosphere. The atmosphere carries it to the winter pole, where it freezes out again. Ultraviolet light works on the methane riding along with it, and produces the soot that falls back down, which stains the ancient terrain red and simultaneously refrigerates the upper atmosphere, enough to stop the whole envelope escaping into space. Meanwhile, at the bottom of the same plane, several kilometers down, the pressure is high enough that some of that nitrogen is liquid, and it finds its way up through the cracks and wets the surface from below. The plane, the sky, the colour, and the wet patches are four faces of one engine, and the engine runs on a heat source that, on the numbers we have, should not be sufficient to run anything, so we come back to that. Because everything in this second half is going to be about following the heat downward, and the first piece of evidence about what is down there does not come from any thermometer, or any spectrum, or any drill. It comes from the fact that the heart is in the wrong place. The strongest evidence that Pluto has an ocean inside it is not a measurement of anything liquid. It is the position of a hole in the ground. Pluto and Charon are tidally locked to one another. Each keeps the same face permanently turned toward the other, and neither ever sees the other move across its sky. When two bodies are locked like that, they are not spheres in any dynamical sense. They are slightly stretched along the line joining them, and that line, the tidal axis, is a real, physically privileged direction. It is the axis along which mass tends to accumulate, because a mass excess along the tidal axis is the lowest energy configuration the system can find. Now, where is Sputnik Planitia? It sits at close to 0 degrees latitude near the equator and at very close to 180 degrees longitude, which is the point on Pluto directly opposite Charon. It sits precisely on the tidal axis, on the far side, as accurately as anyone can measure. That is a coincidence with a probability of a few percent, and a few percent is exactly the range where scientists stop calling something a coincidence and start looking for a mechanism. There is no reason at all for an impact basin to form on the tidal axis. Impacts arrive from wherever they arrive from. The impactor that carved out Sputnik Planitia did not consult Charon's position first. Whatever hit Pluto hit it in a random place. So in 2016, two independent groups, one led by James Keen, one led by Francis Nimmo, published papers in Nature on the same day proposing that the basin did not form where it now sits. It formed somewhere else, and then Pluto rolled. The mechanism is called true polar wander, and it happens to real worlds. If you take a spinning body and add a lump of extra mass somewhere on it, the body will reorient itself so that the extra mass ends up in the position that is most stable for its rotation. This is not the world turning inside its crust. The whole object physically tips over, crust and interior together, until the mass sits where the dynamics want it. Mars has done it. Earth has done it, in small amounts, repeatedly. On Pluto, the argument runs like this. A basin forms somewhere at random. Being a basin, it is low ground. And on a world where nitrogen migrates around the surface seasonally, low ground is a cold trap. Nitrogen preferentially collects in it because the pressure is slightly higher at the bottom of a hole and the temperature slightly lower. Over time, the basin fills with kilometers of nitrogen ice. That accumulation is extra mass in one spot, and Pluto, feeling that lump, reorients until the lump sits on the tidal axis. The amount of reorientation required is up to about 60 degrees, which is to say, Pluto physically rolled over by something approaching a right angle, dragging its poles to new locations because a basin filled with frozen air. There is corroborating evidence for this in the tectonics. A world that reorients by 60 degrees has to change shape as it goes, because its equatorial bulge has to move. That produces stresses in the crust, and those stresses produce fractures in a specific, predictable global pattern. The fracture systems on Pluto, the long troughs radiating away from Sputnik Planitia, sit broadly where a polar wander model says they should. But there is a problem with the whole picture, and it is severe enough that it forces a conclusion about Pluto's interior. Sputnik Planitia is a hole. It is 2.5 to 3.5 kilometers deep. A hole is missing mass. If you dig a basin into a world, you have removed material, and the gravitational pull at that spot goes down, not up. A basin should be a mass deficit, and a mass deficit does not migrate to the tidal axis. It migrates to 90 degrees away from it. The physics runs backwards. Filling it with nitrogen ice helps, but not nearly enough. Nitrogen ice is not very dense. The layer is at most a few kilometers thick, and it does not come close to compensating for the missing volume of a basin that deep. Run the numbers with nitrogen alone, and Sputnik Planitia is still a hole in the gravity field, and Pluto should have rolled it away from Charon rather than toward it. So the extra mass has to come from underneath, and there is a way to get it, and only really one. Suppose Pluto has a layer of liquid water beneath its ice shell. Liquid water is denser than water ice. That is the property that makes ice cubes float. Now suppose an impact excavates a basin. The crust under that basin has been thinned, and the weight pressing down on the liquid layer at that spot has been reduced. The liquid responds the way any fluid under a lighter load responds. It rises. The ocean bulges upward beneath the basin, replacing low-density ice with higher-density water. That upwelling is extra mass, in exactly the right place, and it is more than enough to flip the sign. The basin, which is a topographic hole, becomes a gravitational bump, and a gravitational bump goes to the tidal axis, which means the position of Sputnik Planitia on the far side of Pluto from Charon is an argument, indirect, geometric, and rather elegant, that there is liquid water under Pluto's crust. There is a second, quieter piece of evidence pointing the same way, and it comes from what Pluto's shape does not have. A body that spun rapidly when it was young and then froze solid would keep a record of that early spin in its figure, a slightly flattened shape, an equatorial bulge left over from a faster rotation, frozen into a rigid crust. Planetary scientists call this a fossil bulge, and several icy moons have one. Pluto does not. Within the precision that New Horizons could measure, Pluto is round. No detectable fossil bulge, no frozen in memory of a different rotation rate. A body only loses that memory if its interior has been warm enough for long enough to relax, to flow, slowly, into the shape its current rotation demands. A rigid, frozen-through Pluto could not have done that. A Pluto with a soft, warm interior and a liquid layer inside it could. And there is a third observation that is harder to quantify, but difficult to dismiss. The two hemispheres of Pluto do not look the same. The side that faces Charon and the side that faces away have measurably different geology, different terrain types, different distributions of volatile ice. On a body with no preferred direction in space, that should not happen. The geology should be statistically the same everywhere. It only makes sense on a world where the tidal lock is genuinely old and has had time to organise things, which means the lock, the reorientation, and the interior structure are all part of one history rather than three coincidences. For scale, the basin including its rim structures runs to something like 1,200 kilometres across, which relative to the size of its host world makes it one of the larger impact basins anywhere in the solar system. Whatever hit Pluto did not merely leave a mark, it rearranged the object. That is the majority view. It is not the only view, and the alternatives are serious. In 2024, a set of three-dimensional impact simulations proposed a different source for the mass. If the impactor arrived at an oblique angle, a body around 730 kilometres across, arriving at a slant rather than head-on, then a significant portion of its own rocky core could survive the impact and end up embedded in Pluto's crust beneath the southern part of the basin. Rock is far denser than either ice or water. A buried chunk of impactor core is a mass concentration in its own right, and it would drive the same polar wander with no ocean required at all. On Earth we have a word for that kind of buried density anomaly, a mascon, short for mass concentration, and the Moon is full of them. And in 2025, a study in the Journal of Geophysical Research, planets came at the question from a completely different direction. Rather than modelling the interior, the authors used the shape of the nitrogen ice itself as an instrument. The surface of a fluid settles to match the local gravity field. The frozen nitrogen filling the basin was fluid enough for long enough to have done something similar. So the subtle curvature of the plane, relief variations of less than a kilometre across a basin 800 kilometres wide, mapped from digital elevation models built out of the New Horizons stereo imagery, becomes a proxy for Pluto's geoid. What they found was that the plane is very slightly concave upward, and that shape implies a present-day negative gravity anomaly, a mass deficit right now at Sputnik Planitia. Their interpretation is that the basin has not reached equilibrium. The ocean beneath it is currently refreezing, the ice shell above it is currently thickening, and the mass distribution is still adjusting. Which does not contradict the ocean. It complicates the simple picture. It says that if there was an upwelling that drove the reorientation, that upwelling is now going into reverse. 3 results, 3 mechanisms, 1 basin. They are not mutually exclusive. An oblique impact could have delivered a mascon and a thermal pulse and triggered ocean uplift all at once. But the field has not settled which term dominates. What none of them do is remove the ocean from the table. Because the ocean argument does not rest only on the position of the heart. It rests on something much more direct, which is the shape of every crack on the surface of the world. Water is one of the very few substances on the periodic table that expands when it freezes. This is a genuine oddity. Nearly everything else contracts as it cools, packing its molecules tighter, taking up less room. Water does that too, right up until 4 degrees Celsius, and then it reverses. As it crystallizes into ice, the molecules lock into an open hexagonal lattice that holds them further apart than they were in the liquid, and the volume goes up by about 9%. That is why ice floats. It is why a bottle of water left in a freezer splits. It is why a pothole appears in a road after a hard winter, and why the rock face of a mountain shatters over centuries. Freezing water is one of the most powerful slow demolition tools in nature, and it works by getting bigger. Now apply that at the scale of a world. If a body has a layer of liquid water inside it, and that layer is slowly freezing from the outside inward, then the ice shell above it is being pushed outward from beneath. The world's total volume increases, its surface area increases, and a solid crust that is being asked to cover a larger sphere than it was built for has only one option available to it, which is to crack. The signature is extension, long straight troughs, faults where blocks have pulled apart and dropped. Greben, the technical name for a valley that forms when a strip of crust slides down between 2 normal faults. Nothing crumpled, nothing thrust over anything else, nothing folded, just a surface being pulled in all directions. Now consider the opposite case. Suppose Pluto started cold, accreted slowly, and only later warmed up enough, from radioactive decay, to melt an interior ocean. Then early on the world would have been cooling and contracting, and its crust would have been forced to cover a shrinking sphere. That produces compression, wrinkle ridges, thrust faults, scarps where one block has ridden up over another. Mercury is covered in features like this. So is the Moon, in places. Pluto's surface is dominated by extension. The trough systems, Inanna Fossa, Virgil Fossé, the whole network radiating outward from Sputnik Planitia, are all pull-apart features, and there is essentially no compressional tectonics anywhere on the encounter hemisphere. Not a little, effectively none. That observation is the basis of what is called the hot start hypothesis, published in 2020 by Carver Bearson, Francis Nimmo and William McKinnon in Nature Geoscience. The argument is that Pluto never went through a cold phase at all. If it accreted quickly, if the material that built it arrived over a short enough period, then the gravitational energy released as that material fell together would have been trapped rather than radiated away, and Pluto would have emerged from its formation hot, with a liquid ocean already present, and it has been slowly freezing ever since, for 4.5 billion years, which means every crack on the surface is a record of that freezing, and the reason Pluto shows no early compression is that there was no early cooling to compress it. So what is down there, if the argument holds? Beneath an ice shell on the order of 200 kilometers thick, a layer of liquid water somewhere between 100 and 180 kilometers deep wrapping the rocky core. Stop and let the size of that register because the numbers hide it. Earth's oceans average about 3.7 kilometers deep, not 150, under 3. Our oceans are a film on the surface of a large planet. If you shrank Earth to the size of a billiard ball, the oceans would be a barely detectable dampness. Pluto's proposed ocean is 50 times deeper than the average depth of the Pacific, wrapped around an entire globe. By volume, it may rival everything in every ocean, sea, lake, river, glacier and aquifer on this planet combined. It may exceed it. And it has never seen light. Not filtered light, not dim light. There has never been a photon from the sun at the top of that ocean in the entire history of the solar system, because there have always been 200 kilometers of ice in the way. It has been liquid and dark and undisturbed since before there was a sun in the sky worth blocking. The coldest surface we have ever photographed may be sitting on more liquid water than the planet you are on right now. The obvious objection is temperature. How does anything stay liquid at Pluto, where the surface is minus 229 degrees Celsius and the internal heat flow is 3 milliwatts per square meter? 3 things working together. The first is pressure and depth. 200 kilometers down inside Pluto, you are a long way from the surface, and temperature rises with depth in any body with an internal heat source. The gradient is shallow, but the distance is large. The second is antifreeze. Pure water freezes at 273 Kelvin. Water with ammonia dissolved in it does not. Ammonia is abundant in the outer solar system. It has been detected on Charon and on Pluto's own surface, and even modest concentrations depress the freezing point dramatically, into the range of 176 to 250 Kelvin, depending on the mixture. Add salts and methanol, which are also expected to be present, and the freezing point drops further. The ocean, if it exists, is not fresh water. It is a cold, dense, ammonia-rich brine, and it would be undrinkable and probably lethal, and it would also be very difficult to freeze. The third is insulation, and this is the elegant part. Under the right conditions of pressure and composition, water and gas molecules form structures called clathrate hydrates, cages of water ice with gas molecules trapped inside them. Clathrates are exceptionally poor conductors of heat, far worse than ordinary ice. A layer of clathrate hydrate at the ceiling of Pluto's ocean would act as a thermal blanket, holding the interior's meager heat in and slowing the freezing rate enormously. It has been proposed as the reason a body this small still has anything liquid left after 4.5 billion years. So, a deep, ammonia-loaded, lightless brine, held liquid by pressure, chemistry, and a lid of gas-filled ice on a world we classified as debris. There is also a timing argument buried in the tectonics that is worth drawing out, because it tells you where in the process we have arrived. The extensional features on Pluto are not all the same age. Some cut across older terrain, and some are themselves cut by younger surfaces, and the sequence suggests that the pulling apart has been going on for a very long time, and is not obviously finished. Which fits. An ocean freezing from the outside inward does not do it all at once. It thickens its own lid gradually, and the lid keeps having to stretch, and the cracks keep forming, and each new generation of cracks overprints the last. And that has an ending. If the ocean is freezing, then eventually there will not be one. Some fraction of it has already gone. That is what the 2025 Geoid analysis is arguing when it says the shell is currently thickening and the basin is currently out of equilibrium. At some point, tens or hundreds of millions of years from now, or perhaps considerably longer if the clathrate lid is as good an insulator as proposed, the last of the liquid will crystallize, the expansion will stop, the cracking will stop, and Pluto will finally become the thing we assumed it already was. We happen to have arrived while it is still going. That is not a small piece of luck. Of all the intervals in the 4.5 billion years available, we sent a camera during one in which the world was still moving. And the honest thing to say next is that this does not mean anything is living in it, and nobody serious claims that it does. The ocean sits under 200 kilometers of ice. Its chemistry is loaded with ammonia at concentrations that are hostile rather than helpful. The energy flux available at the rock-water boundary is roughly 3 orders of magnitude below what powers the hydrothermal systems on Earth's seafloor, and those systems are the standard example of life without sunlight, and there is no demonstrated source of the sustained chemical disequilibrium that living things require in order to have something to eat. The organic molecules on Pluto's surface are not evidence either. They are photochemical soot. They are the product of ultraviolet light acting on methane in a process that has been reproduced in laboratory chambers since the 1970s and is observed directly on Titan. Finding complex organics on Pluto is exactly as significant as finding soot in a chimney. What Pluto changes is not the odds for any particular place. It is the inventory of places. It adds an entry to the list of environments where liquid water can exist, and that entry is at 39 times the distance from the Sun that Earth is, on a body 1/459th of Earth's mass, with no tidal heating and almost no internal heat. Which raises the question of what else is on that list that we have not bothered to check, and it is worth noticing how thin the evidence chain is that got us here. There was no drill, no seismometer, no magnetometer reading, no direct detection of anything wet. The case for an ocean inside Pluto is built out of the position of a basin, the absence of a bulge, the direction of a set of cracks, and the shape of a plane measured to within a kilometre from photographs taken during a few hours of a single flyby. That is the entire evidentiary base. It is a remarkable amount of inference to hang on one afternoon of observation, and it is all we're going to have for a very long time. But before we get there, we need to deal with the other body in this system, the one that is half Pluto's size, that has never moved in Pluto's sky, that shut off Pluto's only easy source of heat, and that is currently wearing Pluto's exhaled air as a stain across its north pole. Charon is 1,212 kilometers across. Pluto is 2,376. Charon is 51% of the diameter of the world it orbits, and about 1/8 of its mass. There is nothing else like that in the solar system. Our own moon, which is famously oversized, is about 1/81st of Earth's mass. Every other moon around every other planet is a rounding error next to its host. Charon is a companion, and the consequence of that mass ratio is a fact that most people have never been told, and that quietly dismantles the word moon in this case. Two bodies in orbit do not orbit each other. They both orbit their shared centre of mass, the barycenter, the balance point of the system. For Earth and the Moon, the barycenter sits about 4,700 kilometers from Earth's centre, which is inside the Earth. It is far underground, but it is inside, and that is why we say the Moon orbits Earth. Earth wobbles about a point within itself while the Moon goes round. For Pluto and Charon, the barycenter sits about 2,110 kilometers from Pluto's centre. Pluto's radius is 1,188. The balance point is outside Pluto. It is a point in empty space, roughly 900 kilometers above Pluto's surface, which means Charon does not orbit Pluto. Pluto does not have a moon in the ordinary sense. Both bodies swing around an empty point between them, once every 6.387 days, separated by 19,571 kilometers. It is a binary, two worlds circling nothing, and they are locked. Not partially, not one way, but completely. Pluto's rotation period, Charon's rotation period, and their mutual orbital period are all the same number. 6.387 days. Each keeps the same face permanently toward the other. This is called double synchronous rotation, and among substantial bodies in the solar system, Pluto and Charon are the standard and almost the only example. Here is what that means if you're standing there. You're on the Charon-facing hemisphere of Pluto, somewhere on the smooth ground, looking up. Charon is in the sky. It fills about 3.5 degrees, roughly 7 times the apparent width of the full moon from Earth, which means it covers around 50 times the area. It is enormous. It hangs there, greyish, cratered across most of its face, with a dark reddish cap over its northern pole. and it does not move, not slowly, not imperceptibly. It does not move at all. It has occupied exactly that position, that many degrees above that patch of horizon, for as long as this arrangement has existed, hundreds of millions of years at least, and probably billions. It does not rise, it does not set, it does not track across the sky. Pluto turns beneath it, and the stars wheel past behind it, and Charon stays precisely where it is. It does have phases. Over the 6-day cycle, the terminator sweeps across its face, and it goes from fully lit to fully dark and back. But the disk itself never shifts by a fraction of a degree. It is a moon nailed to the sky, going through phases in place. Now walk. Head in the direction that takes Charon lower in your sky, and keep going. Charon sinks toward the horizon, not because it is moving, but because you are around the curve of a small world. Eventually it touches the horizon. Eventually it is half gone. And then you take one more step and Charon is below the horizon and out of sight, and it does not come back because the geometry that put it there is not going to change. Behind you, that entire hemisphere of Pluto has never seen Charon and never will. There is a line on that world, a fixed circle drawn around it, and on one side of the line there is a permanent moon filling 50 times the area of ours, and on the other side there is nothing but stars, and nobody standing on either side would ever have any reason to suspect the other existed. So how do you get two objects into an arrangement like that? In January of 2025, a paper appeared in Nature Geoscience with an answer that had not been considered before, from Dean Denton, Eric Asfaug, Alexandra Emson-Huber, and Robert Melikian. Previous models of the collision that formed the Pluto-Charon system had done what impact modelling usually does, which is treat the colliding bodies as fluids. At the enormous energies of planetary impacts, that is often a reasonable approximation, and it produces one of two outcomes. Either the bodies merge into a single object, or the impact is violent enough that material sprays out into a disk and reaccretes into moons. That is the standard story for how Earth got the moon. The new work asked a different question. What if you account for the fact that very cold ice is strong? Ice at outer solar system temperatures has real material strength. It resists deformation. It holds together. Include that strength in the simulation, and an entirely new outcome appears, which the authors named KISS and capture. Proto-Pluto and Proto-Charon collide. They do not shatter, and they do not merge. They stick, touching, deformed at the contact point but structurally intact, and rotate together as a single lumpy object, shaped rather like a snowman, for something on the order of 10 to 15 hours. Then tidal torques acting on that spinning elongated configuration pull the two bodies apart again, and they separate into a bound orbit around each other. Both survive. Both keep most of their original composition, and the system that results is a binary, not a planet with a moon, because it never went through the phase where one object was built out of debris from the other. If the model is right, then Pluto and Charon are two objects that met once, held onto each other for half a day, and have been circling each other ever since. And the same mechanism may be how most of the large binaries in that region of space were made. Charon carries its own evidence of a violent history. Running across its surface is a canyon system roughly 1,800 kilometers long and up to 9 kilometers deep. The Grand Canyon is about 446 kilometers long and up to 1.8 kilometers deep. Charon's canyons are 4 times longer and roughly twice as deep, on a body about a third the diameter of Earth's moon. The largest section is called Serenity Chasma, and the reading is the same physics we have already used. Charon had a subsurface ocean of its own. That ocean froze, the freezing water expanded and the crust split open from the inside. South of the canyons lies Vulcan Planitia, a broad smooth plain that appears to have been flooded by cryovolcanic material at some point in the distant past. Charon's surface also carries ammonia hydrates, detected spectroscopically, and that detection has the same awkward implication it has on Pluto. Ammonia exposed at the surface of an airless body is broken down by radiation over roughly 1 billion years. If it is still visible, something has renewed it more recently than that, which means Charon, a body a third the diameter of our moon, with no atmosphere, no tidal heating, and no obvious energy source of any kind, has also been resurfacing itself within the last 1 billion years. The name, incidentally, came from the man who found it. James Christie proposed Charon partly for the ferryman who carries the dead across the river into the underworld, which fits a moon of Pluto perfectly, and partly for his wife Charlene, whom he called Shah. He picked the personal reason first and discovered the mythological one afterwards, which is the only reason the naming committee accepted it. Astronomers have been arguing about how to pronounce it ever since, and both versions appear in the published literature to this day. And then there is the stain. Charon's North Pole is covered by a dark reddish cap about 475 kilometers across. It is called Mordor Macula, and the explanation for it was published in Nature in 2016 by Will Grundy and colleagues, and it is one of the strangest causal chains in planetary science. Methane escapes from Pluto's atmosphere. Not quickly. We established that escape is 100 times slower than anyone predicted, but continuously. Some of that methane crosses the 19,000 kilometers of empty space to Charon and reaches it. Charon's North Pole, because of the system's extreme tilt, spends roughly a century at a time in continuous darkness, at temperatures near 15 Kelvin. That is cold enough to freeze methane out permanently, so the escaped gas cold traps there, accumulating over decades. Then ultraviolet light and cosmic rays go to work on it, and the methane is processed into heavier hydrocarbons, the same tholin chemistry that reddens Pluto, which are far less volatile. When the pole eventually returns to sunlight and warms, the unprocessed methane sublimates away and leaves the tholins behind. Charon's red pole is made of Pluto's exhaled air. That is a physical connection stretching across 19,000 kilometers of vacuum, running for at least millions of years, painting one world with the atmosphere of another, and it is proof of something we have been circling since the beginning. Pluto's volatile cycle is not a local surface phenomenon. It reaches off the world entirely. But Charon is not the only thing out there. There are 4 more objects in this system, and their behavior is the one part of the Pluto story that cannot be described using any of the words we normally use for orbits. Beyond Charon's orbit, there are 4 more objects, and they were all found by the Hubble Space Telescope in the decade before the flyby. Nix and Hydra in 2005, Kerberos in 2011, Styx in 2012. They are small and they are not round. Nix is roughly 50 kilometers by 35 by 33, lumpy, elongated, closer to the shape of a potato than a sphere. Hydra is about 65 by 45 by 25. Kerberos is around 19 by 10. Styx is smaller still, about 16 by 9 by 8. On the scale of this story, they're gravel. The names all come from the same underworld. Nix for the goddess of night and mother of Charon in Greek myth. Hydra for the many-headed serpent that guarded the entrance. Kerberos for the 3-headed dog at the gate. Styx for the river that had to be crossed to get in. The first 2 initials are not an accident either. N and H for New Horizons, chosen deliberately by the Discovery team. The last 2 were named by public vote. In 2013, the institute that found them ran an online poll, and the poll was promptly hijacked in the way that all online polls are. The runaway winner was Vulcan, campaigned for enthusiastically by William Shatner, on the grounds that Vulcan is a Roman god of fire, and also, coincidentally, the homeworld of a fictional science officer. The naming authority declined, on the entirely reasonable technical ground that the name Vulcan had already been used in astronomy for a hypothetical planet inside Mercury's orbit, and reusing it would create confusion. Kerberos and Styx, which came second and third, were adopted instead. But they do something that no other moon in the solar system does, and understanding why requires going back to what a tidal lock actually is. When a moon orbits a single planet, it experiences a gravitational field that has one clear direction, down toward the planet. Over time, tides raised in the moon's body by that field dissipate energy, and the moon's rotation slows until it is showing the same face to the planet permanently. That is why our moon has a near side and a far side. It is why almost every large moon in the solar system is tidally locked. The system has a preferred direction, and eventually the moon settles into alignment with it. Now take away the single planet. Nix and Hydra and Kerberos and Styx are not orbiting a planet. They are orbiting a binary, 2 bodies of comparable mass, swinging around a common point every 6.387 days. The gravitational field out where these small moons live is not fixed. It sloshes. As Pluto and Charon revolve around the barycenter, the direction and strength of the pull on a distant small body changes continuously on a 6-day cycle, and the field never settles into a shape that a moon could lock to. So there is no stable solution available. There is no orientation these objects could adopt that would be self-correcting. Every time one of them starts to settle, the field moves out from under it and applies a torque in a new direction. The result, reported by Mark Showalter and Douglas Hamilton in Nature in 2015, is that these moons rotate chaotically. Chaotically here is not a loose descriptive word. It is the technical term. Their spin rates change unpredictably. Their rotation axes drift and, in Nix's case, can flip over entirely. The pole that was pointing one way ends up pointing another, and there is no way to predict from the current state exactly when or how. The motion is deterministic in the sense that the equations have no randomness in them, and it is unpredictable in the sense that arbitrarily small differences in the starting conditions produce completely different outcomes within a modest number of orbits. Hydra spins about 89 times per orbit, which is a rate with no particular reason behind it. It is simply where the tumbling happens to have left it, and these four are, on top of that, tangled with one another. Styx, Nix and Hydra sit close to a three-body resonance, a relationship between their orbital periods reminiscent of the Laplace resonance that ties Io, Europa and Ganymede together around Jupiter, one of the most elegant and stable configurations in the solar system. But the Jovian version is stable because it sits around a single dominant body. Here, the binary's continuously shifting field perturbs the arrangement and injects chaos into what would otherwise be a clockwork. It is worth noting how this was actually detected, because it was not a matter of watching the moon spin. Hubble cannot resolve Nix into a disk. From here it is a point of light of about the 23rd magnitude, which is roughly 4 million times fainter than the faintest star you can see with your eyes. What Showalter and Hamilton had was a long record of brightness measurements. An irregular object rotating steadily produces a regular repeating light curve as its broad face and its narrow end alternate toward you. An irregular object tumbling chaotically produces a light curve with no period at all, one that never repeats, because the object never returns to the same orientation twice. That absence of a period is the detection. They found chaos by failing to find a pattern. If you stood on Nix, the experience would be genuinely disorienting in a way that no other location in the solar system offers. There is no fixed sky. There is no consistent up. Pluto and Charon would swing around each other overhead in a 6-day cycle, and the ground under your feet would be tumbling with no fixed rotation axis, so that the same star would rise in a different place, at a different angle, on a different schedule from one week to the next. There is no sunrise on Nix. There is no direction that means anything. There is one more detail about these four that points backwards to the collision. They are bright. Nix and Hydra have albedos, reflectivities, in the range of 0.5 to 0.8, which for objects out in the Kuiper belt is remarkable. Most small bodies out there are dark, coated in the accumulated tholins and radiation-processed organics that 4 billion years of exposure produces. These are not. They are relatively clean water ice. The straightforward reading is that they are not captured objects at all. Captured objects would look like everything else out there. These look like debris, fragments of water ice crust thrown off during the event that made Charon still relatively fresh, and kept that way by ongoing micrometeorite bombardment, continually turning over the top layer and exposing clean material. Their orbits support the same conclusion. All four are on nearly circular, nearly coplanar paths, sitting neatly outside Charon in the same plane. That is a very difficult arrangement to produce by capturing 4 separate objects at 4 separate times. It is a very easy arrangement to produce from a disk of debris that settled and coalesced after a single collision. Which means this entire system, one dwarf world, one enormous companion, 4 tumbling fragments, is the wreckage of a single event, still arranged in the pattern that event left it in, billions of years later. New Horizons looked very hard for more. During the approach, one of the mission's genuine anxieties was whether Pluto had a ring, or a debris field, or a 5th and 6th small moon nobody had spotted. At 13.78 kilometers per second, an unseen particle the size of a grain of rice would have hit the spacecraft with the energy of a hand grenade, and New Horizons has no meaningful shielding. They searched. They found nothing beyond what Hubble had already seen, and they held the original trajectory. So the census is closed. Pluto, Charon, and 4 small chaotic objects, in the arrangement a single collision left behind. And that is the whole system, a world with no craters on its largest plane, mountains of water floating on a sea of nitrogen, snow the colour of rust falling from a blue sky that is currently deflating, ice volcanoes with no obvious power supply, an ocean under 200 kilometres of ice, in the dark, since before the sun had planets, a companion half its size that has never moved in its sky, wearing its exhaled air across one pole, and 4 fragments tumbling with no fixed axis, because there is nothing out there stable enough to lock to. All of it on an object we removed from the list because it was too small and too far away to be interesting. Which brings us to the question this whole thing has been holding back, the one about what any of it actually means, and why the answer is not really about Pluto at all. Let me put the energy budget on the table plainly, because the answer to the question we started with is hiding inside it. Pluto has a mass of 1/459th of Earth's. It receives roughly 1/1600th of Earth's sunlight. Its internal heat flow is about 3 milliwatts per square metre against Earth's 87, around 3% per unit area of the heat leaking out of the ground beneath your feet right now, and it has no tidal heating at all, because it and Charon are locked into a perfectly circular, fully synchronized orbit in which neither body ever flexes. By every energy argument available to planetary science before 2015, that object should be finished, cold to the core, a cratered sphere carrying an undisturbed 4.5 billion year record of everything that has ever hit it, and instead, a plane the size of 2 American states with no craters on it at all, turning itself over every 500,000 years. Mountains of water ice floating in a sea of frozen nitrogen. Ice volcanoes that may have erupted within the last few 100 million years. Fields of methane blades 0.5 kilometre tall. A crust that has been pulled apart rather than squeezed in the pattern of freezing ocean leaves. An ocean, probably, 100 to 180 kilometres deep, under 200 kilometres of ice, in permanent darkness. And, reported last week, liquid nitrogen working its way up through cracks and wetting the surface recently enough to still show as a stain. So where is the energy coming from? The honest answer is that we do not fully know. The hot start model, that Pluto assembled fast, kept its accretion heat, and has been slowly freezing ever since, is the best account anyone has, and it fits the tectonics well. But it is a model built to accommodate an observation, and the numbers are tight, and there are people in this field who will tell you frankly that Pluto's heat budget does not close. That is not the disturbing part. Here is the disturbing part. Pluto is not special. There is nothing about Pluto that distinguishes it from its neighbours. It is not the largest object in its region. Eris is more massive. It is not uniquely positioned. It is not uniquely composed. It does not have an unusual history that the others lack. Makemake, Haumea, Gongong, Quaoar, Sedna and Eris are all in the same size class, made of the same broad mixture of rock and ice, formed in the same part of the solar system at the same time, and subject to exactly the same physics. The current estimate for the population of objects larger than 100 kilometres out there is well over 100,000. The number in Pluto's size class is thought to be around 10 or more, and most of them are almost certainly still undiscovered, because they are small and dark and unimaginably far away. If the physics that keeps Pluto's interior warm is real, a fast accretion, a rock-rich core with radioactive elements in it, ammonia and salts depressing the freezing point, and a clathrate lid holding the heat in, then that physics applies to all of them, not to some of them, to all of them, with adjustments only in the 3rd decimal place. Which means the following sentence is now a defensible reading of the evidence. Most of the liquid water in this solar system is not on Earth. It is not on Mars, and it is not in any of the places that appear on the diagram of the habitable zone. It is under ice, in the dark, on bodies we classified as debris and then stopped looking at. Warm is a relative word. We drew a band around the Sun, a range of orbital distances where a rocky world could hold liquid water on its surface, and we called that band the habitable zone, and we have spent the entire modern era of astronomy searching within it. It is a useful concept, and it is not wrong. It is just very small, and it may contain a tiny minority of the actual liquid water in this system, and none of the argument for that conclusion required going anywhere new. It required looking properly at one object we had already dismissed. A surface with no craters is a clock. That was true of Sputnik Planitia, and the clock said 500,000 years, and the reading was so far outside expectation that it forced a complete rewrite of what small distant worlds are capable of. But every object out there is also a clock. Every one of those 100,000 bodies has a surface that is either recording impacts or erasing them, and either answer would tell us something enormous. We have read exactly one of them. One, out of 100,000. And the one we read, We only read because a spacecraft that launched before anyone had a smartphone flew past it for a few hours in 2015 and never came back. We called it dead because we never watched it long enough to see it move. That was true in a way that goes past carelessness. The plane moves at 10 centimeters a year. You cannot see that in a photograph. You can only see it by comparing two photographs separated in time. The atmosphere is deflating by 16%. You cannot see that in one occultation, only across 10 of them spread over 6 years. The wet patches on the glacier are, by their nature, temporary. And we have precisely one image, so we cannot tell whether they are still there. Everything Pluto is doing is invisible in a snapshot. And a snapshot is all we have of one object in a population of 100,000. And the ones we have managed to glance at from a distance keep behaving badly. In 2023, Quad, a body roughly half Pluto's diameter, was found to have a ring, and the ring is in the wrong place. It sits well outside the distance at which theory says orbiting material should have coalesced into a moon within a few decades. It has not. Nobody knows why. That result came from occultations. The same technique, a star fading behind a distant object, a few seconds of data, which is currently the only tool we have for anything out there. This is also, incidentally, where the argument about whether Pluto is a planet stops being a semantic squabble and starts to matter. The dynamical definition classifies a body by its role in its orbital zone. The geophysical definition, which Alan Stern and others have argued for, classifies it by what it is: round, not fusing, complex. The two definitions answer different questions and neither is wrong, but they produce different priorities, and priorities determine budgets. Under one definition, the outer solar system contains 100,000 pieces of leftover rubble. Under the other, it contains dozens of geologically active worlds. Only one of those descriptions gets a mission funded. There is no funded mission to go back. There is a concept called Persephone, an orbiter, roughly a 50-year mission, something near $3 billion, launching in the 2030s and arriving in the 2050s. It is a study. It has no money and no approval. If it were approved today, most of the people listening to this would be in their 80s before it arrived. New Horizons is still out there, past 60 astronomical units, its plutonium output dropping by a few watts a year, expected to keep talking into the 2040s. It is the only spacecraft that has ever been to Pluto, and it is the only one that ever will be in any time frame worth planning around. And Clyde Tombaugh is still on board, 30 grams of him, in an aluminium container bolted to the upper deck, further from the sun than any human remains have ever been and always will be. There is one last person to account for. Venetia Burney was 11 years old at breakfast in Oxford in March of 1930 when she suggested the name. She grew up. She became a teacher. She married and became Venetia Fair, and for most of the 20th century she was a mildly interesting piece of trivia, the woman who named the 9th planet as a child. She lived long enough to see a spacecraft launch toward it in January of 2006, with a student-built dust detector on board that carries her name and is still returning data past 60 astronomical units today. And she lived long enough to see it taken off the list, 7 months later. She died on the 30th of April, 2009, at 90. She never saw the pictures: the heart, the floating mountains, the blue sky, the plain with no craters. All of it arrived 6 years after she was gone. The last thing she knew about the world she had named at breakfast as a child was that a committee had decided it was not a planet. The object itself was unaffected by any of this. It was unaffected by the naming, unaffected by the vote, unaffected by 76 years on a list, and 20 on a different one. Through the whole of it, Lowell's mistake, Tombaugh's plates, the shrinking mass estimates, the demotion, the flyby, the arguments, Sputnik Planitia has been turning over at 10 centimeters a year, red snow has been falling out of a blue sky, and something at the bottom of a nitrogen glacier several kilometers down has been quietly melting. So, why is Pluto more disturbing than we thought? Not because it is frightening. There is nothing out there that threatens anybody. It is disturbing because of what it implies about the reliability of the rest of the picture. We had a category: small, cold, far, dead, and we put 100,000 objects in it, and we checked one of them, once, at speed, and it turned out to be wrong in every particular. The category is still there. The other 99,999 objects are still in it, and the only reason any of them are still classified as inert is that nobody has gone to look. That is the part that should keep you up, not the red snow, not the floating mountains, not the ocean in the dark. The fact that we found all of it in a single afternoon, at a place we had already decided was not worth the trip.